Have you ever just stopped and wondered what is actually going on inside the mind of an AI like ChatGPT? I mean, it really does feel like magic sometimes, doesn't it? But it's not. It is the result of one of the most complex and, frankly, most expensive educational programs ever created. So let's open up the playbook and see how it's done.
So here's the big question, right? How does a machine, a piece of code, go from a totally blank slate knowing literally nothing about the world to being able to write a heartfelt poem about your cat or break down quantum physics for you? That's the mystery we're cracking open today.
Well, the secret is really a two-part education. Think about it like this. First, the AI has to go to the biggest, most chaotic library in the entire universe and basically read every single thing. That's step one. But then, just knowing things isn't enough. It has to go to a kind of finishing school to learn how to actually use all that knowledge, to be helpful. And that's step two. So let's start with that first phase, the universal library. In the AI world, we call this pre-training. And, it's pretty much exactly what it sounds like. We're essentially forcing the AI to sit down and read a massive, massive chunk of the internet. During pre-training, the AI's main job is, believe it or not, shockingly simple. It gets shown a piece of text, and then it's asked over and over and over again, what do you think the next word is? And by doing this billions, even trillions of times, it starts to absorb the patterns, the grammar, the facts, and even the abstract concepts of human language.
And when I say vast amounts of text, I really, really mean it. Just to give you a sense of scale, Meta's Llama 3 model was trained on 15 trillion tokens. A token is basically a word or a part of a word. It's a number so big it's almost meaningless. We're not just talking about reading a library, we're talking about absorbing the entire digital consciousness of humanity. It's wild.
For a long time, the guiding principle, the North Star for AI development, came from this incredibly important discovery. Researchers found that, basically, bigger is better. You throw more computing power at it, you feed it more data, you build a bigger model, and the AI just gets smarter. This insight kicked off an absolute arms race to build the biggest, most powerful models imaginable.
But there's a huge catch to this whole phase. The model's knowledge is completely frozen in time. So if its training data was cut off in September 2023, it has absolutely no idea what happened in October. It's like a brilliant historian who has perfect recall of the past, but has total amnesia about anything that happened after graduation day.
Now, trying to train a model on 15 trillion words is, well, it's a monumental engineering challenge that costs hundreds of millions of dollars. It requires an unbelievable amount of computing power. So how on earth do they pull it off? It all comes down to some incredibly clever billion-dollar study hacks.
The main bottleneck here is memory. A single high-end GPU, which is the specialized chip you need for this, gets completely overwhelmed. It has to juggle not just the model's billions of parameters, but also all the messy in-between calculations, the activations, the learning directions called gradients, and the optimizer states that track its progress. It's kind of like trying to cram the entire Library of Congress onto a single thumb drive. It's just not going to work.
So the solutions really boil down to two big ideas. First, you share the load. This is called parallelism, where you get thousands of these GPUs to work together, each one tackling a little piece of the puzzle. And second, you have to figure out how to work smarter, not just harder, using some really clever software tricks to squeeze every last drop of performance out of the hardware.
And one of the most brilliant work smarter tricks to come out in recent years is something called flash attention. Honestly, the best way to think about it is that it literally teaches the GPU how to speed read.
See, a GPU has two kinds of memory. A huge but relatively slow main memory, and a teeny tiny but ridiculously fast on-chip memory. The old way of doing things involved making tons of slow trips back and forth to that big, slow memory, which created a huge traffic jam. Flash attention completely redesigned the algorithm to do all the hard work inside that tiny, super-fast memory, all in one shot.
And this is what made it such a game changer. Usually in engineering, you have to make a painful trade-off, right? You can make something faster, but it's probably going to use more memory, or the other way around. Flash attention was that super rare, beautiful win-win. It was dramatically faster, and it used less of that precious memory. Just an incredible piece of engineering.
Okay, so our AI has now read the internet. It's unbelievably knowledgeable, but it's not actually useful yet. It's like that person at a party who knows a million trivia facts but just can't hold a normal conversation. That brings us to phase two, fine-tuning. This is where we teach it how to be helpful.
So imagine you ask a raw, pre-trained model a simple, practical question like this. It knows everything there is to know about teddy bears, cotton, and washing machines, but it has no idea how to connect all that knowledge to what you actually need.
And this is what you get. The pre-trained model just continues the pattern. It spits out random facts about teddy bears. I mean, it's not technically wrong, but it's completely useless to you. The fine-tuned model, on the other hand, understands your intent. It gets that you're looking for helpful advice, and it gives it to you. So how do we get this amazing transformation? It happens through a process called supervised fine-tuning, or SFT. Now, instead of feeding it the entire internet, we train the AI on a much smaller, carefully curated dataset of perfect examples. Basically, a whole bunch of instructions paired with ideal, helpful answers that were written by humans.
But, even fine-tuning can be a huge computational chore. Retraining all 100 billion parameters of a massive model is still a really big deal. So, naturally, engineers came up with another brilliant study hack for this phase, a technique called LoRA.
The LoRA method is just genius in its simplicity. What you do is you take that massive pre-trained model and you freeze it. None of its original knowledge gets changed. Then, you just snap on two very small new layers of parameters and only train those. This lets you specialize the model for a new task, like being a helpful assistant, for a tiny fraction of the cost and time.
All right, so our AI has finished its two-part education. It's knowledgeable and now it's helpful. But how do we actually know if it's any good? How do we grade it? Well, it's time for final exams. Grading an AI basically comes down to two main methods. First, we give it standardized tests, a whole bunch of them with acronyms like MMLU, which tests its knowledge on everything from US history to medical ethics. And second, we put them in head-to-head battles, like in the chatbot arena, where two AIs answer the same question, and then real humans vote on which answer was better. The thing is, grading an AI is incredibly tricky. Test scores can be inflated if the model accidentally saw the test questions in its training data. And human preference is, well, it's messy, it's subjective. What one person thinks is a great answer, another person might find totally annoying.
And all of this leads us to the ultimate goal of this entire massive process: alignment. Alignment is the continuous, never-ending effort to make sure these incredibly powerful models aren't just smart, but that they're also helpful, harmless, and honest. It's all about making sure their goals are truly aligned with our human values.
Which leaves us with a really big final question to think about. This technology is moving at a dizzying speed. But if we manage to create an AI that can ace every single exam we can dream up, but we can't fundamentally trust it to be safe and to act in our best interest, then what have we really built? And what does intelligence even mean?